Hello YouTube world, this is Logic Crazy, and I'm Jonathan, and here's yet another tutorial on creating a Java chess engine. In the last tutorial we discussed how alpha-beta pruning works and how it is an extension to the min-max logarithm, and in this tutorial we will at least start creating a alpha-beta algorithm in Java. And you will find several alpha-beta examples, often in pseudocode. But this one specifically for Java, I can guarantee it to work, and I will be explaining it step by step. And I will later have a tutorial to verify that it works. Because in an algorithm that is this difficult for a lot of people to understand, it is very good to have a solid way of testing your algorithm to make sure that it does indeed produce the results that you want. And so what we will start with is the very basic public static, we'll return actually a string, and then alpha, beta, and then we'll have our parameters and make a loop here. Now I'm missing a return statement, so I'm just going to put at the end return and then empty string, just so that it doesn't complain about errors. I like to program it this way. I start off with just getting rid of errors. That way when I type, and if I make a mistake, for instance, you'll notice the little red line and it shows me that there's an error. But and then at the end I have to remember to remove this return string. Now, with alpha beta, there are different ways to go about it, and so this alpha beta is obviously specialized somewhat for my program. Now you have to realize, if you remember in the alpha beta diagrams, if you recall, it's this massive tree. It starts at a root and it gets really big near the bottom. It's usually an inverted tree is how I think of it, where it's big at the bottom, skinny at the top. What happens is there are certain values that are returned. There's an alpha value and a beta value that keep adjusting themselves. And then there is also whichever value is picked. Are we picking the score to be the alpha part or the beta part? And then there's also question of, now that I do not want this alpha beta just to return the score of the optimal route. I want it to return the move of the optimal route, as well as the score. That's fine, but and that is necessary for alpha beta to work, but I need to also return a move. So that is why I have string. It returns not only a move, or not only a score, which could be represented by integer, but it is also representing a move. And so actually what I do is I put them together. When I return things, I return the move and the score after it. So the first 5 characters represent the move, and after that it represents the score. So it would be in the form of return in the form of let's say 1, 2, 3, 4. Take out the bishop, and then the numbers will represent score, let's say. So score could be long, it could be short. All we know is it's not the first 5, so it starts after the first 5 to the end, and that's what the score is, however long that is, indefinite, because a score could be 0, a score could be negative 100, 10,000, you don't know what the score is, and they vary in length. Just to explain that, so my alpha beta program returns a move as well as a score, which often, if I remember right, a lot of algorithms do not. So the first thing is we need a bunch of variables. One of those would be integer depth. We need to know depth because obviously we start at, I always go backwards. I start at a depth of 4 and I go to 0. Instead of starting at 0 and going to 4. That way 0 is a static. I know when I'm ending. I know that I always hit 0 when I've searched to full depth. instead of having a variable, I can have a static 0 at full depth. Anyway, minor details. But I need a depth recorded. I also need integer beta, int alpha. Oh, and one other thing I should say is that make sure you keep the order of these. If you write alpha and then beta, the program will behave differently and incorrectly, because I think I've done this correctly. So beta and then record alpha. Even though the title's alpha beta, just don't flip stuff like that, unless you flip it consistently throughout all the code hereafter. And then we need a string, which is the move. We need to record the move. And there's another thing. We have to record player. And player will be represented either by a 0 or a 1. And the reason we need player is because there's a strange phenomena which happens, which every half move, you have to, in my program, you have to negate the score, the rating. So if, anyway, different programs do that, and I won't go into depth on why, but every other player's turn, every opponent's move, has to return a negative of the score, just so that it's talking about the same side. So instead of talking about their side, when you negate every second depth, you are always talking about it from the same side's perspective. And that hopefully makes sense. All right, so let's get started. We'll start off with the basic. We'll start off with a string list. We need to come up with a list of possible moves that it will run through at each time. And so we'll do this equals possible moves. All right, so these are the possible moves, and it'll obviously start the best one or whatever. Now, just checking here. All right, now we also have to ask a question. What do we do once we've hit the maximum depth? Remember, we start at a depth of 4, and we work our way to 0. And so we need to say, if we've hit the maximum depth, then you return. You don't keep searching. So we'll say if depth equals 0, then do this, and we'll return something. I'm just putting in a blank string. But there's one other case when we quit searching deeper. And if you're not sure what that is, I'll tell you here. It is, and we put an or, not an and statement. And this represents an or. I don't know if I've explained that before, and a double and would be an and. These are for Boolean, so it returns true and false. So this and this or this in this case. And the other case is if list.length is 0. If there are no possible moves. So if you hit a spot where it's checkmate, for instance, no move is possible, and so you cannot keep searching. That would be invalid. And so you end it right there. Now, what do we return? Well, like I said, we return move. Remember, this is the form. We return move, whatever move we're at, and then plus, and I'll put in brackets here, a rating. We're just gonna let's quickly actually make a rating method here. Let's see, rating. I'll put that right above king safe here. Public static and it'll return an integer rating. Oops, there we go. And then we will return, let's say 0 for now. All right. I'll leave that rating as such, but this rating would, of course, evaluate the board. So it would take into account things like material, positional stuff, movability, and we'll get into all that stuff later. All right, so we go back to our alpha beta, and instead of this 1, I will pick in rating, but not just rating. If you remember what the purpose of this player thing was for, this player, we have to negate the score every second depth so that it's always from the same perspective. Because, for instance, from my perspective, the score might be plus 10, and therefore in my program, from the other perspective, it's minus 10. So it's good. I have a good position, and the other side has a bad position. And so that's why I reverse it, so that this logarithm is designed to always talk about the same perspective. All right. So how do I do this player? Now remember, if I times it by player, what I want to do is times it by either a 1 or a negative 1. Now, player is going to be flipped every time by this simple statement. Player equals 1 minus player. Now, as I said before, player is either a 1 or a 0. Either 1 or 0. Now, think about it. If player is a 1, then when it flips, it's 1 minus 1, which turns to 0. And when player is 0, then it's 1 minus 0 turns to 1. So you can see this function here flips from a 0 and a 1. Now, how do I turn a 0 or a 1 into a negative 1 or a positive 1? Now, here is the ingenious method that I use. And feel free to come up with your own version of this solution, but I think mine is fairly elegant. It's player times 2 minus 1. Now, if you do the math, I won't bother to do the math here, but you can look at it on your own and see that player, either being a 1 or a 0, will turn into a negative 1 or a positive 1. And it has to do with this ingenious times 2 is the secret to flipping that. All right, so I'm going to leave the rating like that now and move on. So new line. And in this one, I'm going to say, I'm actually just going to put a comment here, sort. Sort later. The reason I put this here is because not only do we want a list of the possible moves, but it is most efficient for this algorithm to search the moves starting from best to worst. If they could be perfectly sorted, well, obviously there'd be no need for alpha beta, because you would know which one is the best move. But the better they are sorted, the quicker alpha beta can prune or cut off certain moves. And so it will greatly speed up your engine if you can have a good sorting method, which obviously needs a good rating system. So rating is very important. I would say that the two most important things in a chess engine, in my opinion, would be, besides writing code efficiently and all the other stuff, but two of the most essential components is the searching method and the rating method. Not the move generation or the other things. Those are important, but these are the two that really define the good engines from the bad engines. So we'll write a sorting program later. So let's continue. Now what we need is a big for statement for each one of the moves in the list. So how do you do that? Well, we would say for int I, we always start with I in programming, not a, it's just convention. To do that. For I equals 0 to, let's see, to I is less than list dot length. Yes. List dot length, and then I plus equals 5. Okay, then put some brackets in there. So now we're going to loop through each one of these things, and they would be represented by list dot substring, and then it would be I comma I plus 5.